All right, we're going to try to keep this section pretty short. It's essentially a review of linear equations, and this is really the elimination method. So elimination was where you wanted to add your two equations, create this third equation, but when you added those, like right now, if I was to add these two equations, 3x plus 5x would be 8x. Now the nice part about 2y and negative 2y is that adds up to 0y, and I don't need to write anything down. This equals 12, which means I now have this very easy equation to solve, and I could say that x equals 1.5 or 3 over 2. Once I know what x equals, it's pretty easy to figure out what y equals. I'm just going to substitute it in. If I do 3 times 1.5 plus 2y equals 4, well, 3 times 1.5 is 4.5 plus 2y equals 4, so I subtract 4.5 to both sides. 4.5 minus 4.5, 2y equals negative 0.5, and if I have 0.5 and I divide it by 2, I'm going to get y equals negative 0.25. So my answer here, 1.5 comma negative 0.25. That is as straightforward of a elimination problem as you can get. The idea is that worked well because these two variables added to 0. That doesn't happen all of the time. Here, if I tried to add these equations together, nothing's going to cancel out. So I got to play with some other rules that we've used. First off, what I like to try to do is let's pinpoint, you cancel out x or you cancel out y. Whatever you think is easier, pick either. Now, to cancel out, you need one to be positive and one to be negative. So I always look for that. I think it's easier slightly to cancel out the y's here as opposed to the x's. But now I got to do, well, I need to think of something bigger than 3 and 4 that's divisible by 3 and 4, and that number I'm thinking of is 12. So I want to get this column to read 12 and negative 12. The way I'm going to do that is I'm going to multiply the top equation, both sides. I'm going to multiply it by 4. The bottom equation, I'm multiplying both sides by 3. And I'm going to create, now I'm going to rewrite these two new equations when I distribute 20x plus 12y equals 36. I'm going to have 6x minus 12y equals, that's going to be 42. And from here now, if I try to add these up, I get my 26x, the y's have canceled, and I have that equal to 78. This is divisible by 26, and now I know for certain x has to equal 3. So actually combinations is a little shorter. Once I have my x value, I go back to my originals to get my y values. You can use either equation. Let's say I use the top. It becomes 5 times 3 plus 3y equals 9. So 15 plus 3y equals 9. Subtract 15, both sides, cross out. 3x equals negative 6, so we're saying y equals negative 2. 3 negative 2. I hope this isn't going too fast for anyone. If I'm going too fast, please ask me to explain tomorrow. Okay, so here I want to try to use those combinations again. And if I use these combinations again, I essentially, looks like I need to multiply the top equation by 2 to both sides. Right? And if I multiply this top equation by 2, I get 2x minus 4y equals 6. And on the bottom, negative, and this is perfect because I'm thinking I wanted to cancel out my y's. And without a doubt, my y's have canceled just like I wanted. But at the same time, my x's have also canceled. So really, my whole left side is equal to 0 because the x's have all canceled out, the y's have all canceled out, and the right side is equal to 7. And I got to say, that doesn't make a lot of sense. It's not even possible for 0 to be equal to 7. All right. So what I want to do is I want to take a look, and I want to look at on the graphic calculator. I want to actually graph these two equations. And when I say graph these two equations, we need to, if you were to graph these two equations, you need to solve them both for y. If I solved the top equation for y, it would read, let's see, x minus 2y equals 3. So let's say x minus 3 equals 2y. So I would have 1/2 x minus 1.5. 1/2 x minus 3/2. That's the first equation. My second equation would look very similar. I would have 4y equals 1 plus 2x. So all I'm doing here is solving for y. Y equals 1/4 plus 1/2 x. I'm going to put both of these equations into the graph. In fact, you might not even need to put them in the graph. Okay, so what I've done here is actually put these into the graphing calculator already. Notice 0.5 plus 0.25x, that's this equation right here. And then 0.5x minus 1.5, that's this equation right here. And if we graph them, we're going to see, right here that those two lines are 100% parallel. And you could actually figure that out on your own. This right here, this slope and this slope are exactly the same. If you have the same slope and different y-intercepts, then your lines are parallel. They're never going to intersect. So we are going to say no solution. So why did this graph come out to be no solution? Or how could we have said that from this? Well, this statement doesn't make sense. 0 is not ever going to be equal to 7. So when you get a statement like that where all of your variables canceled out, and you're left with this statement that makes no sense, you say no solution. Now I show you one other, this problem looks similar. I'm going to show you one slight difference. If you're thinking to yourself, let's get the x's to cancel out. Let's multiply the top by -2 to both sides. You're going to get negative 4x plus 2y equals -2. On the bottom, we're not changing anything. Just like we wanted, the x's canceled out. Unfortunately, the y's have canceled out at the same time. Means my entire left-hand side is equal to 0. The difference between this problem and the last is the right-hand side is equal to 0. So it makes sense. 0 could actually equal 0. That statement makes a lot of sense. So, let's take a look at our graph so we can make a actual conclusion on this problem. And what I'd like to do is I'm going to graph both of those by solving for y. So I think in the top equation, you could probably solve that for y on your own. Y equals 2x minus 1 when you solve that for y. Second equation, you are going to get the same exact equation, y equals 2x minus 1. So the top equation, the second, and the bottom equation are exactly the same equation, which means if the point is on the first line, it's also on the second line. If it's on the second line, it's also on the first line. So there are many solutions to this problem. So the two different conclusions we want to focus on is, all right, sometimes all of our variables cancel out, and you have this statement that makes no sense, like 0 equals 7 or 0 equals -5. In that case, we say no solution. Or if I have this statement that does make sense, like 0 equals 0, or 10 equals 10, or 3 equals 3, then I'm going to say many solutions. We are going to finish in class with a word problem tomorrow, so why don't you take this into your notes and be ready to go tomorrow. I will see you then.